Hello everyone, this is Jeff of TAOFLEDERMAUS. Today we have 5 12-gauge shotgun projectiles to test out. Now the first 3 rounds are pretty much identical. They have a flat nose. I'm not sure the thinking behind that, maybe to keep the weight as far forward as possible, but they have an aluminum body and a tool steel core. The design was by HW97 Carbine, and Tim from Tactical G-Code machined the fin assemblies. Typically most of the rounds we shoot are slightly smaller than the barrel diameter. You can see a little gap there, maybe 30,000ths of an inch. But these darts were built with very tight tolerances, so the tips of the fins kind of act like skis to keep the projectile centered and going straight down the barrel. And of course the wadding from the shotgun shell is pushing on this round and sealing the gases. Now my role is simply to shoot these things and document how they're flying with my high-speed cameras. Dart 1. I think you hit it. Our first target was a 10-pound disc of lead, 3/4 of an inch thick. You can see the dart impacted it at an angle. The body of the dart remained in the lead, yet the steel core continued flying and stuck into our block of wood behind it. So let's take a look at what happened and why it didn't hit straight. Now the round certainly had a lot of velocity behind it, but it didn't have very much stability. The round oscillated a lot as it flew to the target. The next round is pretty much identical to the first round. Let's see if we have better luck. Fire! Fire!
Ouch. That looked good.
At the range we were shooting at, about 20 yards, Darren should have been able to hit that dead center without a problem. So what went wrong on this one? Instead of a vertical oscillation, we had a horizontal oscillation, and you could see the round waggling along and throwing it off target. Round 3 again is the same as round 1 and 2, but we're shooting out of a high brass shotgun shell. So let's see if a little more velocity will help improve the flight. Hit it.
Where's it going?
I don't know. Now in many ways I am a spectator just like you, trying to figure out what's going on with these, because I'll admit I'm not an expert on supersonic aerodynamics. The increase in velocity seemed to help with the waggling issue, but still the round veered off enough to miss our target. It's easy to blame the shooter, but when the round is curving, the best shooter in the world isn't going to hit anything. So let's see how a pointed aerodynamic nose factors in. Pointed number 4. Is this 4?
Yep.
Yeah, hit it. It hit the lower left one, I think.
Really?
Yeah. Here we see the steel core from the round stuck into the hard drive. So how did it get there?
Oh, here it is.
You found one?
Found it.
The fin assembly?
Yep.
How do you do that?
I don't know.
How's the fins?
They're in good shape.
Not bad. I mean, these have almost no clearance. That one, no, that one's got the metal bit in it. See that? It still has the core.
So these aren't as long as I think they are, huh?
Yeah. One little fin broke off.
That's a different one.
Yeah. This is a real interesting one because the round obviously hit the wood block that the hard drives were set on. The aluminum fin assembly was still stuck in that block of wood, yet the steel core continued flying through there and actually had enough energy to stick into our hard drive. Had we been shooting at longer distances, 30, 40 yards, these rounds would just be flying out of frame, we'd be missing the targets and completely missing the shots with the cameras. Our last round has a plastic ballistic tip on it. Let's see if this helps with flight dynamics.
Okay. Can you load it, or do you have to need a brake action? Oh. It would be. Wouldn't it be easier with a brake action?
No.
Oh, okay. Whenever you're ready, Darren.
It didn't seem like the plastic tip helped in any way in this case. Unfortunately, the light plastic tip added drag to the tip where we don't want the drag. Now this shot really shows you how much the round curves downwards. And if it hadn't hit the table, it would have just nosedived right into the ground after another 10 yards or so. This is the block of wood that the computer hard drives were sitting on. This is what the round looks like. Pretty beat up, but still recognizable. And this is what my poor table looks like. The round just tunneled through there about 18 inches or so. Now I needed a punch and a hammer to knock this fin assembly loose, but this was probably the most impressive shot because it went through 3/4 inch of lead at a 45-degree angle. Pretty impressive, I think. Anyway, I hope you enjoyed this video. Thanks for watching.